Okay, so today I'm going to talk about just real quickly how is a motor similar to a speaker, and they're pretty much the exact same thing, which you might be confused about. So let's talk about that. So how does this work? This motor. So basically, what happens is I'm going to connect the electricity, and the electricity is going to go through the wires, and it wants to go from here to here and get back to the other end of the battery, right? It wants to create a circuit, but there's no circuit because there's no metal between here right now. So what I do is I'm going to let it go through this coil, but you got to remember that this coil has one side that's entirely shaved and the other one's only halfway shaved. So the electricity can only go through here half the time. And so since it only can go through half the time, we can get it to push and let go and push and let go and push and let go. So it's intermittently pushing and letting go of the system. And so therefore, it's able to push it when it's timed. And so that is almost exactly the same thing as a speaker. And so if I was to take this and take this off and put it through here and connect it to the two wires, which I won't. And the reason I won't is because this is not, this wouldn't be intermittent. It would just be all the time. And so it would just push and you wouldn't hear anything. In order to hear something, you need a vibration. And so what ends up happening is going through the wires is almost identical to what we have when we had the tin can phones. And so if we go back to the tin can phone idea, what was a tin can phone idea? In fact, I'll go nice and large here. Is that when you spoke into one tin can, right, it vibrated and then it sent those vibrations through the wire. And so basically what we have um, is we have a microphone. And in the microphone, what you do is you actually will speak into one cup. I'll be like, where am I? I'll be like, hello, hello, hello. And I'll speak into the cup. And then that will send electricity through the wires. Um, and there's a battery connected to the situation. And instead of sending electricity from the batteries just in a constant stream, it will send electricity in the exact vibration of my voice, which is happening right now in here. It's the vibrations of my voice are vibrating the microphone. I'm not sure if you can hear that. I don't think you can. When I tap it, maybe, I don't know. But those vibrations are going through the system and coming out your system. So it will send it intermittently to the speaker. And so what is a speaker? A speaker is literally the same thing. So now we're getting vibrating. It won't be from directly from the battery because the battery would just be constant stream. It will be vibrating um, pulses of electrons, which will cause the coil to vibrate, which causes the cup bottom to vibrate. So I'm going to draw this for a second just so you can kind of see what is going on. So I would have a person, and the person is going to talk, and I shouldn't spend too much time on the person. Um, so the person is going to talk, hello, and they're going to talk into a basically a speaker. It's going to funnel the noise down, and the sound actually will vibrate a coil next to a magnet. And so you need a coil and a magnet. So the sound will vibrate the coil next to the magnet. And since this is connected up to some sort of a battery, there'll be some sort of battery in the system, right? Since it's connected to battery, it will cause um, the electrons to want to flow through the system, through the circuit. And when it flows through the circuit, it flows with the same vibrations of the person's voice, which means that if it's connected somewhere else to another coil, here's another coil, which is next to another magnet. Here's another magnet, which is on the bottom of another speaker, then this will vibrate and the sound will come out. And so this is a clever way of taking sound, which is what's called a mechanical wave. Mechanical meaning you can actually feel it vibrate, and turning it into electricity, which can travel in electrical waves. And these are waves of electrons. And so these electrons, when they pulse in the bottom of this cup, they turn back into sound, which is basically, like we said, it's a mechanical wave. So in the intermediate, you can't like literally, I can't take the cord of my of this, and I can't like and listen to it. You know, you can't hear it vibrating. You can't even feel it vibrating, but it is vibrating. It's vibrating electrically. And so when those electrons go through, they're going to create sound coming out the other side. And essentially, that's what a speaker is. If you looked at it in more detail, a speaker has a coil of wires, and then it has a strong magnet. And the coil of wires is just like that. It's connected to a paper cone. And if you notice, pretty much all speakers are made of paper. And so the paper vibrates easily, and it makes loud sounds. And so that turns the electricity vibrating in and out, it turns it into sound that you can hear. So in a nutshell, that's how a motor is similar, pretty much the same thing as a speaker. I mean, the setup is almost exactly the same, isn't it? So anyways, that's the main idea to start us on our way. Okie dokie. Let me see if I can get back and turn this off.